Hi class, I wanted to start with a first video on just reviewing some very basic indefinite integrals. If you think about going back to Calc 1, Calc 1 was really the study of limits and then derivatives and their applications. And then at the end of Calc 1, what you did is you learned the basics of integration. Well, Calc 2 is all about integration. What we're going to do is we're going to learn, we're going to continue on from the basics that we learned, just like you did in Calc 1 for the derivatives. Then we're going to do harder and harder and harder and harder integrals, and then we'll learn about the applications of the integrals. So to be able to be successful in Calc 2, you have to have a strong understanding of the basic rules of integration. So that's what we're going to spend doing through our first week. All right, so on the screen in front of you right now, you'll see all the basic rules of integration that you would have learned in Calc 1. Starting with the integral of a constant, the general power rule, natural log, exponential, base E, exponential base A, whatever that is, whatever real number A is. And then you have the trig integrals, and then you have some inverse trig integrals. So for this first video, what we're going to do is we're going to concentrate on the constant rule, general power rule, natural log, and the exponential integrals. All right, well, let's jump right into it. All right, so let's go over the first basic one, rules of antiderivatives, the most basic one being the power rule, which is just integral of x to the n with respect to the x variable. Well, that's equal to, you take whatever the n is, you add 1, you divide by n plus 1. And then because this is an indefinite integral, don't forget your constant of integration. And obviously this is for any real number other than n is equal to -1. Obviously if you get -1, -1 plus 1, you get to divide by 0. And if you go back, we see the case when n is equal to -1 is actually the natural log. All right, regardless. Let's do some really simple examples to start. So if we integrate t cubed dt, well, here my n is 3. So it's just n plus 1, 3 plus 1, over n plus 1, 3 plus 1. Well, 3 plus 1 is 4, so it's t to the 4th over 4 plus your constant of integration. All right, here's another one, a little bit more complicated. If you integrate 1 over t squared, well, this doesn't look like x to the n. All right, it looks like 1 over x to the n. So what you have to do is you have to rewrite this. Obviously, using your rules of exponents, you bring this up as a negative, so it's the integral of t to the -2 dt. Well, great, looks like x to the n. So -2 plus 1 is -1, over -2 plus 1 is -1. Well, negative exponent comes down, we can bring the negative up, and you just get -1 over t. Obviously, this just becomes t to the first power, so we just leave it as t plus your constant of integration. Not too bad, pretty straightforward. All right, you can always check your answers by taking the derivative. For example, if you take the derivative of this, you should get t cubed. See, derivative of t to the 4th is 4t cubed. 4 cancel. You indeed get t cubed. All right, so if you're ever unsure, you could just take the derivative. All right, so here's what I want to do a couple times throughout this video. I'm going to give you guys some problems to try. So what you should do is as soon as I put up the first one, like this one, the integral of the square root of u du, you should pause the video right now and give it a shot and see what your answer is. Unpause the video once you have the solution, and I'll show you what the solution is. All right, so I'll be quiet for a second while you pause the video and try this. So unpause it once you've found the solution. All right, if you've done this correctly, you're going to use the general power rule. You're going to rewrite the square root of u as u to the 1/2, and then go through the simple general power rule. You should get this. All right, let's give it another try. Try this, the integral of just dx. That's weird. You know, there's nothing in there. So what's in there? So pause the video and write what you get. All right, if you've gotten this integral and unpaused the video, it's just the integral of the constant 1. Well, that would just be 1 times x plus c, or x plus your constant of integration. All right, let's do some more advanced rules. All right, let's do the constant multiple rule and sum and difference rules. Start with the constant rule. So if you have a constant times a function of x, you can just factor out the constant and just integrate f of x. All right, you can do this for any real number. And then the sum and difference, if you have two functions being added or subtracted, you could just do their integrals separately. All right, let's do a couple examples. Let's start with this one. So you're going to integrate 2v cubed. Well, the 2 is just a constant, so you can just factor this out. So you get 2 times the integral of v cubed dv. Well, just from there, you just do the general power rule. 3 plus 1 is 4 over 4. The 2 and 4 simplify, and you get v to the 4th over 2 plus c. Again, if you take the derivative of this to check, the 4 comes down in front, so you get 4v cubed divided by 2. The 4 and 2 would become 2v cubed. We got it. Yes. All right, try this one right here. All right, so pause the video again and see if you can get this one. So it's the integral of 12 over v to the 5th, z to the 5th dz. All right, so if you tried the problem and unpaused it, all right, you take the 12 out, write this as z to the negative 5th dz. If you do it correctly and then simplify, you should get this. Same thing over here. Try walking through this problem. All right, I'll pause the video and give it a shot. All right, if you do this correctly, you just integrate term by term by term, and you should get this. All right, let's do a harder one right here. So let's integrate x squared plus 1 over the square root of x. It's like, yikes, this one looks crazy. Doesn't look like any of the other rules we've had so far, so how would you even go about tackling this one? Well, the first thing you have to do is you have to rewrite the integrand into something you can use. So for this one, we want to rewrite it into something using the general power rule. All right, so I'm going to split the fraction. All right, so it's going to be x squared over the square root of x plus 1 over the square root of x. Now what I'm going to do is I'm going to rewrite the square root of x as x to the 1/2 power, like this. So then once you have it here, you could just use your rules of exponents here. This becomes x to the 2 minus 1/2. 1/2 comes up as a negative exponent. 2 minus 1/2 is obviously 3/2. So this just gets rewritten as this. Once you have it here, guess what? You can use the general power rule. All right? It's very easy to find the antiderivative at this point. So 3/2 plus 1 is 5/2, so it's x to the 5/2 over 5/2. Negative 1/2 plus 1 is 1/2, so x to the 1/2 over 1/2. You would bring these fractions up as their flip, so this would be your final answer. Not too bad. So even though it looks hard, the trick is just to rewrite it. All right, let's do some transcendental functions. If you have e to the x, then the derivative of, if f of x is equal to e to the x, well then the derivative is just e to the x. All right, if you have f of x equal to a to the x, well then derivative is just natural log of a times a to the x. And then these two other ones are just to recall from the chain rule. So if you have e to the k to the x, the derivative is k, e to the kx, and the same thing here. All right, a to the kx, then it's k times natural log of a times a to the kx. So what we can use is we can use these to help us find the antiderivatives. All right, so we have the following formulas. The integral of e to the x is just e to the x. The integral of e to the kx is just e to the kx over k. The integral of a to the x is just a to the x over the natural log of a. And a to the kx, all right, the integral of a to the kx is just a to the kx over k, natural log of a. So these formulas you can just directly apply to problems. All right, so let's do a couple. So this one here, if you have 9 e to the t dt, factor out the 9, you get the integral of e to the t dt. Well, that's just equal to integral of e to the t is e to the t, so it's just 9 e to the t. Pretty straightforward. Taking actually the integral and derivatives of the exponential function is actually really easy. If you look at this one, if you remember this one, this was one of the first rules. If you have x to the negative 1, that's equal to the integral of 1 over x dx. That always just integrates directly as the natural log of x. All right. So the reason you need to take the natural log, the absolute value of x, if you remember, logarithm functions are not defined for negative values. All right. So if you take the absolute value sign, it keeps it positive. That's what we need. All right. So if you look at this example right here, 4 over x dx. Just factor out the 4, you get the integral of 1 over x dx. Well, 1 over x dx just integrates as the natural log of x, and you just get 4 times the natural log of x. All right, that's the end of our first slideshow. We'll come back and do some more ones. With our next example, we'll get into some definite integrals. All right, thanks, class.